out of place. And mesh is used to add structural support to hold them upright. It affects 1 out of every 2 women over the age of 50, and most women have it, but they don't know they have it. Only about 11 to 12% need surgery for it, and of these, 29% will need a reoperation. The current standard of care is a polypropylene mesh implant, which initially works well, but the body begins rejecting it, and we believe that to be caused by M1 macrophages. So problems with the mesh, as I said, the body begins to reject the mesh, and there's chronic inflammatory reactions against it. Basically what happens is the macrophages kind of encapsulate the mesh and force it out of the body. If you can imagine being stabbed, something going into your body, it's the same feeling except the mesh is being excreted outside of your body. So it's very painful, very uncomfortable. And like I said, M1 macrophages are what's causing this. So what we do in my lab is we wanted to drive them from an M1 character to an M2 character. M1 macrophages are pro-inflammatory and M2 are anti-inflammatory. So previous studies have shown that polypropylene, when had IL-4 added to it, it drove the M1 to an M2 character. All macrophages are in a spectrum. No macrophage is exactly M1 or M2, it's a spectrum. And macrophages, if you don't know, are immune cells that go to areas where there is a foreign body. The mesh is a foreign region, so the immune cells go towards it to kind of force it outside of the body, and that's when the encapsulation occurs. It's being forced outside of the body. So M2 macrophage cell markers. My mentor did his experiment on M2 macrophages, and I did mine on M1. So going back to what he did, just to give you guys like a basis on how my results are going to look and to show you what to expect. He saw that in arginase, which is a cell marker for M2 macrophages, it was more increased when IL-4 was loaded onto the mesh. So as you can see, all that red is arginase, which is an M2 cell marker again, and it's more increased in this region, which is IL-4 loaded. So when you load the mesh, it drives M1 towards M2 and leads to more IL-4 cell markers, and leads to more arginase cell markers. Cell markers on top of the cell, cells have multiple cell markers, but these cell markers tell us that we're looking at macrophages, and more particularly, M2 macrophages. And effect on capsulation. Capsulation is when the mesh is excreted from the body, and the pristine mesh, the original standard of care that's used to treat women with pelvic organ prolapse, is rejected and encapsulated. So what this shows is how, it's kind of hard to see right now, but all the blue in here is collagen, which is basically scar tissue formation. And going over to here, when IL-4 is loaded onto the mesh, there's much less scar tissue, much less collagen, basically better incorporation because there's less encapsulation. And these would be healthier and these are not healthy. So Ames. That was done for M2. So the Ames in my experiment would determine if M1 character is correlated with more encapsulation. And we did immunofluorescent staining with iNOS, which is an M1 macrophage cell marker. So what we're looking for is to see if in iNOS there will be less of that when IL-4 is added to the macrophages. And we also did different cell markers such as F480, which is a pan macrophage cell marker, CD68 cell markers, and CD11B cell markers. Methods. So in order to add the IL-4, which is what we're trying to do, we had to add, we had the mesh, we had a base layer of mesh, right? On top of that was chitosan, which is positively charged, and dermatan sulfate, which is negatively charged, and then we had the IL-4 on top of that. And these units were repeated for 10, 20, and then 40 and 60 layers to make sure that the IL-4 would adhere to the mesh so that it could be a proper vehicle to affect the M1 polarization towards M2. And it was a nanometer in thickness. These are very thin mesh slices. They're about a nanometer in thickness. And then the mesh implant with the IL-4 added was then added into the mouse in this subcutaneous pocket. The mouse had pelvic organ prolapse, by the way, so we're looking at the effects of that. The staining was called immunofluorescence staining. Basically, the staining was, so after we got the samples out of the mouse tissue, they were in a paraffin wax.